today we build one thing end-to-end, a SQL agent that takes a plain English question, writes a SQL query against your own database, runs it, and answers in natural language. We're using Azure OpenAI with function calling, an Azure SQL database, and a thin orchestration layer you could host in Azure Functions or container apps. By the end, you'll know the architecture, the exact build order, the decision at each step, and how to keep the model from doing anything destructive. This is a pattern you could rebuild from memory. Let's wire it up. Here's how the pieces fit. A client sends a question to our orchestrator. The orchestrator calls Azure OpenAI with the user message plus a tool definition that describes a single function. Run a read-only SQL query. The model responds with a function call containing the SQL it wants to run. Our code executes that query against Azure SQL using a least privilege account, then feeds the rows back to the model for a final natural language answer. Key Vault holds the database connection string and the API key. Notice the model never touches the database directly. Our code is the only thing that opens a connection, and that's deliberate. Build it in this order so each layer is testable. First, provision Azure SQL and a read-only login scope to just the tables you want exposed. Second, deploy an Azure OpenAI model that supports tool calling, like GPT-4o. Third, extract your schema, the table and column names with types, because the model can't guess what it can't see. Fourth, define the run query tool and wire the orchestration loop. Fifth, add guardrails and validation before any query executes. Don't skip ahead. If the read-only login isn't locked down, no amount of prompting saves you later. The single biggest quality lever is the schema you give the model. Don't dump the entire database. Hand it only the relevant tables, their columns, types, and a one-line description of each, plus a few example rows if values are ambiguous. This grounds the model and dramatically cuts hallucinated column names. For large schemas, retrieve only the tables relevant to the question instead of pasting everything, which also saves tokens. Put this schema in the system message and state the rules plainly. Select statements only, always add a row limit, and never modify data. The model follows clear constraints far better than vague ones. This is the heart of it. We expose one function to the model with a strict JSON schema, a single string parameter holding the SQL query. The model decides when to call it and what query to send. Our code intercepts that call, validates the SQL, executes it against the read-only connection, and returns the rows as JSON. The model then summarizes those rows for the user. Keeping the surface to one well-described tool keeps behavior predictable and easy to audit. Never run model output blindly. Before executing, validate. Parse the SQL and reject anything that isn't a single select statement. No insert, update, delete, drop, or multiple statements. Enforce a row cap by injecting a top clause or limit. Set a command timeout, a few seconds, so a heavy query can't hang your service. And rely on defense in depth. The database login itself is read-only and scoped, so even a query that slips past your parser physically can't write. Log every generated query for review. These are not optional niceties. They're the difference between a demo and something you'd let near production. Now prove it. Ask a simple question and confirm the generated SQL appears in your logs and matches intent. Ask an aggregation question, like totals by month, and check the numbers against a query you run by hand. Then try to break it. Ask it to delete a table and confirm the request is refused or fails at the read-only boundary. Test an ambiguous question and see if it picks reasonable columns. Watch token usage and latency, since a big schema in every prompt adds up. When real questions return correct, grounded answers and destructive attempts fail safely, you're done. To recap, the orchestrator, not the model, owns database access. You ground generation with a focused schema, expose one read-only query tool, validate before executing, and back it all with a least privilege login. That layered design is what makes this safe. Your one actionable takeaway: build the read-only database login first, before you write a single line of agent code, because security you bolt on later is security you forgot somewhere. Model names, pricing, and tool calling APIs change often, so check the current Azure OpenAI docs before you ship. Build it, break it, then trust it. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.